Hello again, everyone. Today I'm going to talk about quantum mechanical relativity, and I'm going to explain what it is and what it has to do with nature, and also how it ties into biology, chemistry, and physics for unified theory, and that's reflected throughout nature. So first I'll just go over the three energies again real quick. In binary relativity, in one of my earlier videos, I explained the mathematics, so I'll just go over the energies again real quick. Now, one opposite state, a positive energy, is E equals mc squared, and the mathematics is in the other video. Now, a negative energy is GE equals msr squared, a gravitational energy, and the mathematics again is in the other video, binary relativity. And the third state, quantum mechanical relativity, because that's binary relativity, gravitational energy equals msr squared. Now, quantum mechanical relativity is fusionary energy equals mc squared plus or minus msr squared. And the full mathematics is fusionary energy equals mc squared plus or minus msr squared divided by the square root of v squared divided by c squared. And I go into mathematics in general in binary relativity, one of the earlier videos. So, okay, I'll just explain the plus or minus with another diagram here, since I don't have a chalkboard available yet. Okay, the fusionary energy, it can exist in three states too. And it's based on the evolution of the star and also the mass of the stars and speed of rotation and other factors. So the first state is probably newly formed stars or failed stars and maybe low mass stars, and its fusionary energy equals mc squared minus msr squared. And yeah, that's just a weaker form of the fusionary energy dealing with low mass stars, failed stars, or other stars. Now, as the star evolves, it develops core reactions, core fusionary energies, and this is where the plus or minus comes in. Now, the second form of fusionary energy is mc squared plus or minus msr squared, and this has to do with, you know, evolved higher mass stars, most stars that are out in the universe probably. And I'll just go over the third state and then I'll explain the quantum mechanical part. The third state is fusionary energy equals mc squared plus msr squared. Now, this has to do with core reactions, but also antimatter-matter conversions, AMCs, as we call them. So, yeah, that occurs at the core of a star, and also where antimatter and matter meet out in the universe. So, back to quantum mechanical relativity, the plus or minus. Now, basically in the core of a star, it's additive, so that you have a core reaction where gamma rays are released and huge amounts of energy are released in the core of a star, or when antimatter and matter meet. So that's additive. Now, there's a zone of probability around the core of a star because it's not a solid object. Basically, the energy has to move throughout it, and in the zone of probability, it's plus and minus, where there's micro reactions helping to sustain a macro reaction, which also ties into quantum mechanics. And around the core, there's a zone of probability where it's both. And around the core also, the gamma rays get released in the core, and then they interact with a zone of probability around the core, and then they get broken down further by the negative energy that surrounds it, mc squared minus msr squared. So it's quantum mechanical not only because in a star it's in two states in one energy, but also because micro reactions help to sustain the macro reaction in the star, so that, you know, hydrogen atoms fusing in the core of a star and also probably interacting with some antimatter that's created and destroyed in the core of a star gets broken down by the macro energies, and because, you know, those micro reactions create huge amounts of energy and then it gets broken down by the macro energies into visible and other wavelengths of light. So basically, it's basically a core reaction in a star that gets broken down further and further from gamma rays into smaller and smaller wavelengths of light. And that's quantum mechanical relativity. So, basically the three energies, there's two opposite states and one fused state. And this is mirrored throughout nature, whether you're talking about biology, chemistry, or physics, or any, mixed state. And that's why it's a unified energy, or a unified theory, because really, in terms of biology, if you think about just humans, there's two opposite states and a fused state, whether, two opposite sexes, and then there's reproduction. And also, with biology, you could have two opposite states, like an animal versus a plant, but there's also a fused state where there's sort of a mix of both, kind of like a Venus flytrap, where a plant's eating an animal. And in terms of chemistry, there's protons versus electrons, two opposite states, and there's a fused state where protons are fused with electrons, creating neutrons. So it's mirrored throughout nature, two opposite energies and three states, and it's mirrored throughout the sciences too, which makes it a unified theory. But also, a fusionary energy, with there being three energies like this, it doesn't break down in a singularity. You have two opposite energies, but when they get fused into the singularity, the laws of physics don't break down. They just fuse in a fused energy state, so that at the singularity, at the point of the Big Bang, there's still a viable law of physics that doesn't break down. And actually, as the singularity evolves into the universe, these branch out from the fusionary energy and creating, two opposite states, but based on the evolution of stars and the singularity itself. So it's basically like a cyclic sort of thing, where one star, one fusionary energy can evolve into different death states and different other states as matter and energy are recycled throughout the universe. So that's quantum mechanical relativity and an overview of binary relativity and just basic add-ons to general and special theories in relativity, but a huge leap in theoretical physics. Alright, thank you for your time, and remember, explore your world, explore your universe, explore yourself. And I'm out.